Hello everyone and welcome to a new discussion which we are going to have today on conjunctive use of ground and surface water under this groundwater engineering course. First we will see what exactly conjunctive use means here and then we will move forward in our discussion. So, first thing is that the combined use, when we say conjunctive use, I mean combined use and development of surface water and groundwater, as we know that both are directly linked and important from groundwater engineering point of view also, from recharge point of view, from pollution point of view, from all different aspects of groundwater engineering is all connected with surface water. So, the combined use of and development of surface and groundwater as a strategy for sustainable resource. Our aim is that in all places everywhere the water should be available round the year, and that is by a sustainable resource, so that the resource remain available for all the time, even whatever the climate change which are happening. So, we should adopt the climate change. So, climate change adoption is called conjunctive use of surface and groundwater. Now, this the strategy of conjunctive use of groundwater basically to increase the overall flexibility of water supply by utilizing both sources of water. In the beginning of this course, we discussed what is basically surface water, what we mean basically surface water, which includes water in the streams, rivers, includes reservoirs, ponds and even small tanks also. So, that means that a use and that the strategy has to be so that our overall flexibility remains about the supply of water, and that is why in our we said the sustainable resource. So, that should be there because we might be using in combination with surface water and groundwater together. So, basically this strategy focuses on advantageous role of groundwater for water storage. Why? Because we know that there are several advantages with groundwater compared to surface water. Further distribution and treatment through biological processes is not only increasing water supply, but also improving water quality and distribution. The advantages which we have discussed earlier associated with groundwater is that the water remain for very long time in our aquifers. The quality of water, or because of through this infiltration and percolation, lot of processes keep happening and they I would say improve the water quality of groundwater. Temperature of groundwater is also almost same all the time, and groundwater does not get much affected through the weather. So, all these advantages are there, and that is why the focus here in our or emphasis have been that how best the groundwater should be stored, and whatever the supply requirements are there the groundwater should be used, and also keep good quality of groundwater and its distribution. So, it is available almost everywhere. Now, we know in previous discussions also we have discussed when we were discussing about pollution, that one of the reasons of our regime, groundwater regime, is getting polluted because of the pressure of utilization and population growth. So, increasing population and decreasing surface water supplies, these are the two problems which has put increased pressure on the groundwater supplies, because a lot of water bodies which used to exist at many places, even if you see that almost all village, all towns and some big cities had several water bodies, surface water bodies I am talking, and now slowly these water bodies are getting disappeared, and that means that it is affecting our groundwater regime. The recharge is not available, the water for recharge is not as available as used to be, and that is putting a big pressure on our groundwater supplies. If this budget remains in several places, if this budget remains in negative or in deficit, then we are having problems. So, if we look from time frame, then we say that at the scale of 10,000 years, the groundwater is renewable. So, in that scale it is fine, but what is happening, on the scale of 100 to 1000 years, it is not. So, it is not renewable in that sense, and that is real problem or challenge. So, as we know that certain part of this country, water now being pumped out, which is about 10,000 years old, and that means we are now going to exhaust at places whatever the groundwater is available, and further that also means that we are going deeper and deeper in the wells. So, it is a kind of alarming situation. And if we see that what happens when lowering the water table, as two schematics are here, and when the water table or the cone of depression expands because of over exploitation of groundwater, the regional water table will go down, and what it will destroy? It will destroy wetlands and rivers, and this is what it is depicted in these two schematics. That when river was flowing, we had the swamps along the river, there were greenery all around, and we had a higher water table, means water table was close to the surface of the earth. But because of our requirements of water has increased, or requirements of groundwater has increased, like through industries or settlements, our swamp became dry, our rivers became dry, and our lot of pumping is being done as depicted here for industrial purposes. And what happened? Our water table has gone down. That means now we are at places as mentioned, we are exploiting water which of 10,000 years old. So, this is going to create big problems at several places unless we recharge our areas. So, diverting water away from recharge areas also causes the water table to drop. If we are by some means, by some our actions, if these water bodies, surface water bodies are drying up or disappearing, then this is what it is going to happen. And as I have said in the beginning of this discussion, that surface water and groundwater are directly linked. The areas where we do not have any surface, because recall that when we started exploration about the groundwater, what he said that in direct evidences and indirect evidences of presence of groundwater. So, under direct evidences, these things were there, like river, like ponds, swamps and other things, that were clear indication that water is available at shallow depth. But if this is the situation, it is again clear indication that water is available or groundwater is available at a deeper levels and very deep levels. However, if we reverse this groundwater flow, then cone of depression creates a local slope that induces pollutants to flow into the well. So, in the previous discussion when we have been discussing pollutants, that is also that is what it is important. Higher the withdrawal, more the withdrawal of water, you are forcing this the base of that cone of depression, which is near on the surface, and large area is getting empty, and whenever there is a rain or some other infiltration happens, then it might take the water or the pollutants from surface to subsurface. So, again two schematics, one is the water table is at high levels, not much pumping is there, just home water supply or municipal supply, there is a simple septic tank, and the regional groundwater flow is there. And these contaminants, though they are there, but they are not much going in towards the well, they are going away from the well. But over withdrawal of the water, then when you are having a large irrigation well and that contaminated water supply is there, because this the septic tank which is shown here is now polluting your groundwater supply to the house or to the settlements or affecting your municipal water supply, and this is what happens. So, over exploitation will not only harm the vegetation on the surface, water bodies on the surface, but also it can bring contaminants, pollutants into the, and it can change the direction of flow of the movement. Because of this, as you can see here, it is from right to left, whereas all these arrows are showing towards the well because of large irrigation well, lot of pumping is being done for irrigation. Further, if it is a coastal area, then we are having another problem, and that problem is saline intrusion. So, around coast, salt water will replace fresh water, and it is a very dangerous situation, and it is happening in many parts of even this country in coastal parts. And this replacement of fresh water by salt water becomes permanent, and then your well becomes useless, because you do not need the sea water in your wells. So, here again two schematics. What you are seeing that the sea or ocean is here, water table was an initial stage water at a shallow depth, and you are having fresh groundwater. But when you over exploit the fresh water or groundwater, then this salt water keep entering, because the water level or water table here is lower than the sea level. Sea level is here. If it is same, then the flow will not occur. But if it is not, if your groundwater table is lower than sea level, then the salt water will, the intrusion will take place, and your well will start getting sea water. So, very dangerous situation. That is why the title of this discussion is conjunctive use of groundwater and surface water. The balance has to be there, so that such incidents do not occur. Now, if we further you might have heard land subsidence, and maybe in future we might be discussing on when we over exploit the groundwater, land subsidence can also occur in some places, and there are examples even in this country also. I will very briefly give that example. Through radar remote sensing or SAR interferometry techniques, people have detected land subsidence of quite significant magnitude in the city of Kolkata, and that means the cracks in the buildings, and of course, it is lowering the water table. So, over exploitation of groundwater in certain kind of formations can create land subsidence, and of course, this effect is permanent, and because pore will collapse and land subsidence will occur, and it becomes permanent. So, if suppose a scenario is like this, that you are having sediments, they are completely saturated with water, by some means if you take out the water. So, what this is what it is shown here is confined aquifer kind of conditions. You have taken out the water, you take out the water, then there will be collapse, compaction you can say, when you squeeze out the water, and this is what the result would be. So, there will be collapse because lot of exploitation of water through heavy irrigation. Groundwater fissures and scarps develop. As you can see, it is collapsing, and these are the signatures of collapsing. See what happened here. And now your pores are not saturated with water, now they are saturated with air. So, your aquifer becomes thinner, air filled pores collapse and grain pack together more tightly, and result is subsidence, and there may be even damage to the houses, roads and other things also. So, this is another problem when we are not using, when we are not going for conjunctive use of ground and surface water. Further, groundwater overabundance, that may be another problem, that at only some places in because of certain circumstances, rising water tables may initiate slope failure, and this can happen in some part of mountainous terrain, or because of suddenly there is now a canal is there that is recharging your groundwater regime, and the water table is becoming quite shallower, and then can create such problems also. So, groundwater overabundance, lot of groundwater is available, but it is a not very common phenomena. So, here again when you see the initial stage which is shown through this figure A, and then what happens in the next time, then when you are having too much of groundwater, a lake might form here, everything is saturated, water table becomes very shallow, and when wet and sliding surface phase, the slump moves, and that is also creating a slumping kind of, or a, you can say, landslide kind of thing. And in the field, this is what happens if you see in the field conditions. So, because of certain arrangement of formation, weak layer, potential failure panel, and then you are having water table which was at a sufficient depth, everything was intact, nothing was happening. But because of overabundance of groundwater, because of some activity in upstream side, maybe a reservoir has come, maybe a big water body has come, that is recharging the groundwater regime, maybe unlined canal might have come, and that is might create some problems. And I know that there is a one place because of this Indira Gandhi canal which is coming to Jodhpur city, and people are facing different kind of problems. The problem of very shallow groundwater conditions. So, they have to think that how they can lower this water table in that area. So, now in this one we will see that initial benefits of irrigation agriculture, and this is agriculture productivity of irrigation systems. Irrigation system mainly we are talking about canal systems or others. So, surface water irrigation development, when this happens, then you are having that you are utilizing the surface water, it is fine. Then unsustainable surface water irrigation. So, you are going with the time here, time indicates in the same area. So, excess recharge, rising water table. So, this blue line shows the water table. So, rising water table, soil waterlogging and salinization, and this is exactly what is happening in case of Punjab and some parts of Haryana, where salinization of soils is happening very clearly because of shallow groundwater conditions. And why shallow groundwater conditions? Because of irrigation, and the drainage system is not there. So, whatever the fertilizers and other salts which are put, the water evaporates and that left on the surface, and that becomes a crust on the surface of few millimeters or maybe centimeter, and the entire land becomes unusable from agriculture point of view. So, if we depend only on the surface water, this is what happens. But when we go for the groundwater development, means exploiting groundwater, then the water table goes down, your surface water will come up in that sense. So, improved agriculture productivity through groundwater use and drainage. This is a very good situation in which we are using conjunctive use of groundwater and surface water. But when we go for unsustainable conjunctive use, then what is happening? Excessive groundwater use, your water table is going deeper down and continuously falling water table. When we come to real sustainable, a balanced situation, then our water, surface water should have a higher position as compared to groundwater, that is the good one. And what happens? Optimize agriculture production under conjunctive irrigation area or use. So, here these are the average groundwater levels in blue color. Here what we have discussed is agriculture productivity of irrigation system in the dark grey color, and this is what the ground level is here. So, you can think that if a conjunctive use is not done or that balance is not struck for any area, these are the problem which might occur, these are the problem which might occur. Too deep groundwater level. So, this is the best situation where you are having such kind of thing that the water is available, productivity is also okay, and your groundwater levels are not going too deep. Now, examples of conjunctive use and development application include maximizing surface water use in high flow periods. When you are having lot of surface water, use it, while allowing groundwater to remain in storage. So, when you are having surface water, maximizing surface water use in high flow periods, and groundwater should remain in storage. Groundwater should be only withdrawn or drawing on groundwater resources during dry season to maintain steady supply. So, when you are having surface water bodies, use them. same these surface water bodies will also recharge groundwater body. So, the lot of water which comes on surface through the precipitation or rain will remain for some time as surface water body. That water should be exploited rather than at that stage the groundwater, and let that surface water body should also recharge groundwater regime. And when surface water bodies dries up, then one should go for exploiting groundwater, and that will provide a balanced approach for any areas and will not cause any kind of or will not cause much problems. That means that what we are suggesting, that groundwater should be used as a buffer storage to bridge the dry season, but also to prevent water logging and salinization. Because this water logging and salinization problems are because of also shallow groundwater conditions and soil conditions also. Everywhere, even there sandy soils are there, it is not necessary that this salinization. If clay soils are there in some area, then and groundwater tables are very shallow, then these problems comes. So, we can use groundwater as a buffer to bridge the dry season, that means to have sustainable supply of water during dry season from the groundwater resource, and this can be a very common characteristics of conductive use. So, for different conditions, different uses of water, surface water initially, then groundwater, and then again monsoon comes, so surface water, then groundwater. So, conjunctive use can also draw the surface water flows as a way to minimizing groundwater table depletion and salinization. So, that what you are aiming? You are aiming to minimize the groundwater depletion and at same time also maintaining the salinization or minimizing salinization as well. So, such approach will maintain an overall water balance, and that is what conjunctive use is, which we are talking. So, between groundwater recharge and surface water recovery. So, here we are seeing a comprehensive kind of diagram. What we are going to discuss here is that the stream aquifer systems, it is necessary to consider surface and groundwater management as one. Both usage of both types of water, groundwater and surface water, should not be looked in isolation. That is the point here. It should be looked as from groundwater or water management point of view, it should be looked as one resource, and that is overall the water resource. So, here what you are seeing, that groundwater withdrawal and surface water diversion is taking place here, and at same time you are having the rain and snow, that is overall precipitation you are talking about, then canopy interceptions and ET, that is evapotranspiration is there. Some water even after the irrigation, that is return water through irrigation comes, and that is now infiltration here. There might be some overland flow of this rainwater, and a lot of water will go to unsaturated water zone, and that will have a water table also below that. You might be having interflow, that is within the top part of the earth in the soil zone, which is also shown here with the black dashed line, and then you are having a stream scenario. So, a stream is also there, alluvium are there, groundwater ET is there, because there will be ground loss to if a surface water body is there and temperature are quite high in tropical or subtropical climate, then groundwater evaporation can also take place, not transpiration but evaporation mainly, and unsaturated zones can also go for that, and soil zone also can contribute. So, this is a scenario when we are having a sedimentary rock at the top, and then you are having a solid bed rock like this. So, this basically maintaining our balance or conjunctive use of groundwater, that we know that it is a water as a cycle. So, here it is represented again as a cycle, water cycle, and balance is there and things will keep happening. But anything, if input is less and exploitation remain same or more, you will have problems. Or if input is more, your exploitation is less, you may have another kind of problem. Nonetheless, what we need overall is a balanced use. So, when water can flow from a stream to aquifers, here we can also see that part to the aquifer or vice versa, whether your stream is affluent or influent, it need not to be good to have two separate policies or plans for the same water. What we need overall management of water, and that includes surface and groundwater both. However, the legal separations of groundwater and surface water or administration of groundwater and surface water management by separate agencies is generally there, but should be coordinated manner. So, you might be hearing lot of disputes of river water in between two states within India, or river disputes between two countries also, river water, or they are talking about surface water disputes. But generally so far there are no much disputes about the groundwater resources, because the political boundaries, many political boundaries are along the rivers, or our rivers are making political boundaries. So, half part of the river is on one state, half part is another state. Now, both needs the water. So, when both are requiring lot of water, then what to do? So, there are disputes and people keep arguing that this state need this farmer need this, and similarly between the countries. But these disputes or these administrative problems are, or political problems are only for the related with surface water now. But in future, if we are having that much understanding of groundwater, that problem might also come, but that is not there. Second thing is the management by the separate agencies within one state, and there are irrigation departments, there are groundwater department. Now, both are not talking to each other, whereas for the better management of water, both should have the coordinated efforts, as this is what coordinated manner. So, if that is there, the water problem will not be there. So, there is a basically need for management of ground and surface water together as an element of interrelated system, and is most critical when demand exceeds supply. No, but let me also add here, sometimes it becomes the reverse also, when supply is more and people will keep complaining. And this happens when in one state you are having a barrage, and in another state the river comes. So, when barrage, when in the monsoon season, when lot of rain is occurring, that barrage is diverting the water directly to the river, and then a state which is in downstream can complaining that lot of water or flooding is occurring in my state. But barrage cannot hold water for longer time. It is mainly for regulation of water, not for storage. And this I will give you example between state of Haryana and Delhi even this year, Hathi Kund barrage, and Delhi government blame Haryana that they are releasing the water. They cannot, because the barrage is not for storage. So, whatever the water from upstream is coming, they are just passing that water to the Yamuna river. So, in downstreams, if lot of water suddenly starts coming, there will be flooding. So, such problems will keep coming, but that is when you are having excess water. But here we are also talking about the when demand exceeds the supply, then different kind of disputes or different kind of argument will come. Further, as we have been also discussing earlier, that over pumping of aquifers near a river could deplete the surface resources. When lot of water is required for irrigation or other purposes, people go to the near surface resources, near rivers or water bodies and so on. And while development of a losing river could reduce the normal recharge to an aquifer system, because a river or a pond or a reservoir, these are our recharge bodies also, following a spread method of recharge. And if that is reduced, the water in that is reduced or no water left, then it will not recharge our aquifers. So, on a larger scale, on a regional basis, the incremental drawdown caused by any single pump may be small, That means that it should be very local. The effect of that pump on groundwater water table or the drawdown of that pump has to be very local. If it is lowering too large area, that means what I am saying, that if the base of that cone of depression becomes very large, that means you are over exploiting water, then the apex of the cone will go lower and it will create problems. Not only you would be putting more energy, but other wells in the surroundings will get also affected. So, it is the cumulative effect of many pumps that can cause a depletion of total resource. So, if too much water is exploited from all around, this is what is going to happen. So, individual user has no economic incentives to reduce pumping, because they do not care about others, and that can create. So, in many states in India, now one cannot install their own tube well. They have to take permission, or the water supply is done through some municipal network of water pipes and other things. They are not allowed, and this has happened in case of Telangana also. And because of many such efforts, now water table is rising there, as earlier also I discussed. So, situation becomes more worse when groundwater pumping results in a reduction in the flow of surface waters. Too much exploitation of groundwater can create. So, the balance has to be struck in all cases, everywhere. Groundwater users may feel social pressure if a neighbor's well is adversely affected. However, this pressure is not experienced when reduction in availability of surface water affects an unknown user which may be exploiting, and it is a very far location. So, individual litigation among tens, hundreds of users along a stream aquifer system could present a legal nightmare. And in some parts where really there is a scarcity of water, such things are happening. Some type of institutional control should be there, some legislation, some organization, some department which having the complete watch on such systems and making workable management approach for this use of groundwater as well as surface water. So, the management plan of water might be a total ban on groundwater withdrawals during such times that the flow of river fails below a specified value. But writing here or discussing here is fine, but when it comes on the implementation part on the ground, these things may not work for long. It requires too much policing kind of thing. So, however, would not prevent the stream flow from falling even more, as the response time of an aquifer is quite long. You cannot just recharge your groundwater aquifers, it takes time. So, even if you stop getting water withdrawal from a stream, it will not recharge your groundwater regime immediately. It is a very slow process, and we have seen that what is the this movement of groundwater. In some places, in some formations, it is centimeter, millimeter per day, or in some places might be even meter per day. So, in order to fully protect the rights of senior surface water users, groundwater pumping might be prohibited altogether. This is such suggestion, not in all parts of India, but where we are having more water problems. While this would serve one purpose, only one purpose, it would also eliminate the use of groundwater reservoir for storage of excess water and recharge. Further, in addition, groundwater development usually provides water supplies in excess of stream flow alone, and in most extreme case occurs when a river fed by mountain runoff flows across an aquifer system that receives no recharge from precipitation. So, there again might be a problem. So, what we are basically discussing, that the entire management should be very judicious, very wisely should be done about the water resources. Now, under such conditions, the river is only source of water for both groundwater and surface water users, and in this extreme case the river and aquifer system conjunctively use to maximize benefit. And if the water is used for irrigation, there is a demand only part of the year, because in round the year they are not doing irrigations. But nowadays, like in many places, earlier we used to have just 2 crops, 3 crops. Now people are going for even 4 crops. So almost round the year they are going for irrigation, and there the groundwater, they are relying more now on groundwater and lowering the groundwater table. So the remainder of the year the stream flow passes downstream, but it should happen then only, and will maximize the benefit would occur if some of the water flowing in the non-growing season could be stored for use when it is needed. But when water is available, nobody bothers. When water is not available, then lot of crisis or complaints will come. So, what we are discussing at this point is the better irrigation and crop management, and if that is done, then this will accomplish by taking advantage of delayed response of aquifer system. Means the recharge which happens at very slow rate, that can manage very well with this. So, here what we are looking, wells located away from river and pumped during the irrigation season would draw water from storage at that time, and when the cone of depression reaches the river, the infiltration would be induced mostly during the non-growing season. So, 3 scenarios: pre-irrigation, stream water irrigation and groundwater irrigation, and this is what exactly is conjunctive. The purpose of discussing is the conjunctive use of water. So, when precipitation is occurring, the other process like ET is also happening, recharge is also happening, stream in, you are having water in stream, groundwater flow is also there and it is effluent. Now, when you have a stream water irrigation, when you are bringing water for irrigation from a stream, then stream diversion might take place, irrigation is being done, and of course, the groundwater flow continues towards the river or stream, and same time input is there, fantastic. Similarly, when groundwater irrigation is being done, what is happening? You are lowering the groundwater table and irrigation. So, you are inducing here during the non-growing season infiltration, and probably this kind of approach on a local scale it can be done, but otherwise see that in the warmer season the water has disappeared because groundwater irrigation is happening. So, in a local area it can be done very well managed, but if it is a large area involved, then such things becomes very difficult to do. So, well located closer to the river would pump only the near end of the irrigation season. So, while the benefits of conjunctive groundwater and surface water use are obvious, the implementation of management is not easy. This is the point I have just mentioned. It is not easy in a small scale, on a village level or a taluka level, probably it is, but on a larger scale it is not. Similarly, legal frameworks about the utilization of water in India is different in different states, and that is why there are a lot of disputes between the states also. So, there are number of different management plans might be possible depending on the different water resources, and then suggestions for conjunctive use. An application of groundwater might be allowed to a large amount of water, but would be available only during the non-growing season. So, a total volume not nearly as great might be allocated if it were to be pumped during the irrigation season. But how you will maintain, how you will monitor all these things, that is the real challenge. And that is why many times we are having lot of problems about water, especially in dry season when we are depending more on groundwater. So, both plans or different plans could protect the senior water rights equally. So, this conjunctive use of ground and surface water involves a complex interaction of several physical systems. Computer models can also be employed for the optimal management system, There are a lot of development is taking place about this computer model which integrates the following systems into one model, that is the surface water reservoir, a hydraulically connected stream system, aquifer, irrigation, agricultural plots, water supply and observation well, and an artificial recharge zone. That is the one of the long term best solution, that you recharge, keep recharging your groundwater regime, and lot of other problems will not erupt. So, those kind of efforts should be there, and they will help about this to struck the balance between groundwater and surface water. So, these models or these systems can be implemented to store water during wet periods like in rainy season, monsoon season, for release during the subsequent dry periods. That is the best practice if it can be followed, and these models can be used for planning purposes up to 6 months in advance. And computer models are routinely used to determine the interaction of groundwater and surface water for purposes of allocation of water rights. Further, models are also available that when for irrigation for different kind of crops water will be required, and how this water can come, that can also be modeled. So, an important aspect of well management conjunctive use is continued monitoring of quality and quantity of water, or both types of water, water sources and water extraction rates, as well as meteorological forecast to help managers adjust responses in time. And this is a again meteorological forecast, this many times it is very challenging, it is not all the time we are getting very accurate forecast. So, even if make adjustment to your plans based on the forecast, sometimes that may also give a lot of problem. So, all these require information inputs from stakeholders, for example, through extraction rate reporting and local hydrological, meteorological and geophysical characteristics about underground storage availability, production and natural recharge capacity, etc. A lot of information will be required to develop such models, and the analysis of the best methods for conjunctive use along with necessary staff training. Now, communities and authorities with sufficient resources may also choose to employ more sophisticated hydrological models, but that will require more data and that will require more people to have that thing. But anyway, that will support our decisions. So, it can become a decision support system to identify and inform most beneficial methods under various hydrological scenarios. Of course, the day by day our weather forecast is improving, and many farmers are now taking advantage on their mobiles, they are getting information. So, if they are putting their farm for irrigation today, but they know that tomorrow there is going to be the rain, then probably they will not use that groundwater if they are going to use today. So, a better informed communities and authorities, of course, then we can manage our water resources in much better manner, but that requires lot of efforts, lot of data and more accurate predictions about weather. So, in areas where conjunctive use is new or not a formalized approach, we only go for this kind of approach when we are having problem. The areas we do not have problem, nobody bothers about that, but that is the problem really, because tomorrow it is going to have, that area is also going to have face problems. So, if it is not formalized approach, policies and institutional frameworks for restriction may have to be established to ensure balance and coordinated use, and that is what the conjunctive use. So, environmental benefits, if we go for conjunctive use, first one is avoid aquifer and surface source over extraction, degradation, and supports a more natural water balance where both types of water, that is groundwater recharge and surface water recovery, is possible. This conjunctive use will also reduce the risk of water logging and salinization, which we have discussed also. Now, socioeconomic benefits, definitely they are there, the increasing water security and supply stability even in locations with high interseasonal water variability will provide huge benefits to the society. Increases water availability throughout the year, reduces agricultural losses from interruptions in irrigation and improves the food security. What are the opportunities? Improve sustainability of surface and groundwater management while still meeting water demands. Low environmental impact, provides several socioeconomic benefits. Implementation at a local level with direct benefits to the community. That is the best approach. Involve the local people to solve their problems so that they will have a sense of ownership, and when that sense occurs, then probably these things can be managed very well. So, now we are coming almost in the last part of this discussion about conjunctive use of ground and surface water. What are the problems? What are the barriers are there? The barrier is a high degree of coordination required between the water users and the whoever is maintaining, the authorities you can say, to ensure the benefits are maintained and over exploitation is avoided. Sufficient level of data on both water resources is required, that is about the surface water and groundwater. When surface water is getting depleted by water level in the rivers is going down, as we have discussed earlier, that at certain level we should stop using that water, because otherwise the this also harms the aquatic life if no water left in a river for some time in a year. So, it can be challenging to monitor illegal or unregistered groundwater use on private grounds, for example private wells, and that may impact groundwater availability regardless of management plans. So, the challenge is here is basically how to monitor all these, the use of water, and because at a local level in a individual houses, how can you manage that or how can you monitor that thing. So, finally, responsibility of surface and groundwater resources may lie with different authorities, society, or even different administrative boundaries. Individuals are also responsible for this, and if we all go from that point of view, then we will have water in our wells or in rivers round the year, and this is what is conjunctive use of ground and surface water. So, with this I thank you all.